Hi guys, can you hear me? Yes. Okay, good. All right. I hope you guys have been well. Been a little sick. Okay, can you see my screen? Okay, good. Good stuff. So you can answer here if you want. Okay. So today we will be talking about the 1993 Math Counts chapter sprint. So I guess we'll just go right into it and start off with this problem. What part of half of a square meter is 1/2 meter squared? Express your answer as a common fraction. This one's a little confusing, I guess. Okay, since this is the first one, I'll go ahead and explain it because it's not a big deal. So this one's more of the problem, the confusing part is in the wording. So it says what part of half a square meter, so 1/2 meter squared. So what part, so it's like x of 1/2 meter squared is equal to 1/2 meter squared. So that's just 1/2 times 1/2. You get what I see? So uh, good try. It's not 1/4 or 2. Yeah. So the point of this one is you have to read carefully. So it's 1/2 of a square meter is just this. And then 1/2 meter squared is actually equal to this. 1/2 meter times 1/2 meter. So if you solve this for x, so this is meter squared. Because each one of these have a meter, so it's just meter squared. So the meters cancel out. So it's just 1/2 times x equals 1/2 times 1/2. So then what is x? So it's basically asking 1/2 x equals 1/4. What is x? Right, x would be equal to 1/2. So this one's, again, this one's mainly the wording. So what part of 1/2 a square meter is equal to 1/2 meter squared? Oops. And then 1/2 meter squared is 1/2 times 1/2. Okay. Yeah, this explains it. So this is 1/2 meters squared, and this is x times 1/2 meter squared. Okay, so if the square root of 50 plus the square root of 75 lies between two consecutive integers a and b, where a is less than b, what is the value of b? All right, nice job, guys. The answer is 16. So for this one, not too bad. So the square root of 50 is slightly larger than 7. So it's only a little bit larger than 7. So it's equal to like 7.06 or something like that. And then the square root of 75 is larger than 8. So it's 8.5 something, something like that. So then it's just like 7.06 plus 8.5, and that's 15 point something something. We did this something doesn't really matter. It just, you know that it's between 15 and 16. So the B is 16. Similar to sprint problem 1991, number 21. Okay, a number is chosen at random from the following set. What is the probability its reciprocal is greater than 1? Express your answer as a common fraction. Sorry about that. All right, nice job to the people who got 2/5. That's the correct answer. So the point of this problem is you have to know what a reciprocal is, and the reciprocal of a number is just 1 over that number. So it's like, what's the reciprocal of 2? That's just equal to 1/2 if you take the reciprocal of 2. So, and there's also a key point. If you take the reciprocal of anything less than 1, it becomes greater than 1. And if you take the reciprocal of anything greater than 1, it becomes less than 1. So for example, if you take the reciprocal of 1 over 0.25, because 0.25 is less than 1, this becomes 4, which is greater than 1. So basically, the problem asks for what is the probability that you choose a number that is less than 1. And you see there are 4 numbers that are less than 1 out of the total 10 numbers. So the probability you choose a number that is less than 1 is 4 out of 10, which simplifies to 2/5. Okay, 2 boxes contain a total of 150 coins. 17 coins are moved from the first box to the second. The first box now contains half as many coins as the second. How many coins were originally in the first box? Right, nice job. The answer is 67. So this one's solving a system of equations. You can write out the 2 equations. It's basically, so the first box is x, and we'll let the second box be y. So x plus y equals 150 coins. This is the total number of coins. And it says 17 coins are moved from the first box to the second, so x minus 17. And now the first box contains half as many coins as the second box, so the second box has y plus 17. And then you solve this system of equations. So I just opened up the bottom, so you get 2x minus y equals 51. If you simplify this, and then that with x plus y equals 150. So I'm just solving the system of equations, and I can solve for x easiest by just simply adding them together. So we get 3x equals 201. And then you solve x equals 67 coins. So again, system of equations, write out your variables, write out your equations, and then solve the equations. Okay. Two trains are headed directly toward each other at rates of 80 miles per hour and 120 miles per hour. How many miles apart are there 1 minute before impact? And express your answer as a mixed number. All right, good try, guys, but I think you got it wrong. Almost though. I think probably everybody just had a small calculation mistake. I don't know why. So if they're headed directly at each other at rates of 80 and 120, so 80 and 120. So since they're heading towards each other, the total velocity that they're approaching each other is 80 plus 120 because they're directly going at each other. So they're traveling towards each other at 200 miles per hour. So 200 miles per hour, and then it asks how many miles apart 1 minute. So it's basically asking if you're traveling at 200 miles per hour, how many miles will you go in 1 minute? So basically, if 260 minutes x in 1 minute, so that's just 200 over 60. And you simplify this, it asks you for a mixed number. So first we can take the zeros out and then divide by 2. We get 10 over 3. And then when you simplify 10 over 3, you actually get 3 and 1/3, not 4 and 1/3. So close, but not quite. All right. So probably just a small calculation mistake on you guys' part. Okay, let's try this problem. A band found they could arrange themselves in rows of 6, 7, or 8 with no one left over. What is the minimum number of students in the band? Okay, the correct answer is actually 168. Nice job to the people who got it. Um, this problem is, if you know GC, LCM and GCF, you should be fine. Sorry, excuse me. It's a bit cold. So for this problem, we have 7 and 8. You can guess and check, but since 168 is so large, you probably won't be able to guess it. We factor 6, that equals 2 times 3. And then we factor 7 is equal to 7. And then 8 is equal to 2 to the third. And then by the rule of GCF, we take all the like factors, so that's these two, and we grab the greatest power, so 2 to the 3, and then we multiply by everything left, 7 times 3, which comes out to be 168. So again, to review you real quick, for GCF, we take this would be LCM. For LCM, we factor all the numbers. We circle the like factors. We pick the like factor with the greatest exponent, which is 2 to the 3 in this case. And then for these, they don't have any like factors, so we just multiply them by our like factors. And then we get 168. So you guys should go review LCM GCF if you couldn't solve this problem. Okay. 8 circular cookies are cut out of a rectangle of dough measuring 4 by 8 inches. How many square inches of dough are left over? And express your answer in terms of pi. Right, nice job. So the total area of the rectangle is 8 times 4, which is 32. And each circle has an area of 1 pi, and there's each circle. So 32 minus 8 pi. Okay. Cards are randomly drawn one at a time without replacement from a standard deck of playing cards. What is the probability expressed as a common fraction? The first 3 cards chosen are all clubs. Yeah, 13. So there are a total of 52 cards, and 13 clubs, 13 spades, 13 hearts, 13 diamonds. Okay, not quite 11 over 714. Good try, Reese. Oh, nice job, Claire. So actually 11 over 850. So nice job. So for this problem, basically, so so the key point in this problem, it says you're drawn one at a time without replacement. So that's the main point. So if it were with replacement, then it would just be 1/4 times 1/4 cubed. That's with replacement, but it says without replacement. So first off, for your first card you're drawing, the probability that you get a club is 13 out of 52. That's the probability you get a club on your first draw. That simplifies to 1/4. So that's the probability you get a club on your first draw. So after that, there are now 51 cards left because you took one of the cards, and there are only 12 clubs left because you also took one of the clubs. So that's the probability you get a club on your second draw. And on your third draw, there are 50 cards left, and instead of 12 clubs, there are 11 clubs because you drew one before. So the answer to this question is 1/4 probability for the first club times 12 over 51 for the second club times 11 over 50 for the last club, right? I think probably just a slight calculation error. Yeah, so that's the main point. And then once you simplify this down, it comes out to 11 over 850. So pretty easy once you know the idea. Okay, if a and b are numbers such that a plus b equals 18, what is the smallest value of a squared plus b squared? Right, nice job. The answer is 162. Uh, hmm. I guess you can do it algebraically, but the easiest way to do it is just like guess and check, because you don't have very many options. And then in the end, you figure out if both of them equal 9, then it gives you the smallest value for their squares, sum of their squares. Okay, find the sum of the reciprocal. No, we're going to skip this one. Okay, the length of a side of a cube is 8 units. Express as a common fraction the ratio of the number of square units in the surface area of the cube to the number of cubic units in the volume. All right, nice job. The correct answer is 3/4. I think there's just a slight calculation mistake there. Um, right, so the surface area of the cube, so the cube length doesn't actually matter. You can just call it A. So the surface area is 6A squared because each little square is A squared, and then there's 6 of them. To the ratio of, oh wait, it does matter. Just kidding, sorry. Uh, to the ratio of A to the power 3, because that's the volume. And that gives you 6 over A, which is 6 over 8 in our case, which simplifies down to 3/4. So probably not fastest way to dash it first. Easier to just set it as A and then try solving it from there. Okay, the diagonal of a cube is 5 inches. How many square inches are in the total surface area of the cube? Right, the correct answer is 50. I'll go ahead and explain this one because if you don't know how to do it, you probably won't get it very quickly. So if you didn't know, when it says diagonal, oops, let's see if I can draw this better. When it says diagonal of a cube, uh, so let's say this was our cube. Like so. Okay, so this is our cube. This is kind of right here. Um, okay, so that's our cube, right? I hope you can see it. Um, let's see. Okay, these are dotted lines because you can't actually see them if you're looking from the front direction. So I hope you can see my cube pretty well. Okay, so the point of this problem is when it says the diagonal of a cube is 50 inches, is 5 inches, it doesn't mean this diagonal right here. That's not 5 inches. What it means, what it actually is looking for when it says the diagonal of the cube, it means from this point to this point over here. So opposite corners. So this would be 5 inches. So this would be 5. Oops. This would be 5 right here. From this corner to this corner. So it goes through the cube. It's not on the outside of the cube. And if you didn't know, if this is A, then the diagonal through the inside is equal to A root 3. You can solve that out by first finding this diagonal, which is A root 2, and then using the Pythagorean theorem with this side. So it's 2A squared plus A squared is equal to X squared. So A root 3 is equal to 5. And it asks for what is the total surface area of the cube. So what we're looking for is 6A squared. So let's just square everything, and we get 3A squared equals 25. And the question asks for 6A squared, which is going to equal 50. Okay, so again, the point of this problem is if it's talking about the diagonal of a cube and it doesn't say the surface diagonal, it's talking about the diagonal that runs to the inside. And you should just memorize that the diagonal that runs to the inside is equal to a root 3 if the side length is a. And if you know that, this problem becomes pretty easy. Okay, let this little symbol thingy be defined. I hope you can see this. This symbol be defined as AD plus BE plus CF. If 2, 3, 4, 6, E5 is equal to 67, then what is E? What must E equal? I'll draw the symbol over here just in case you guys can't see it. So this is A, B, C, D, E, F, and then the question asks for 2, 3, 2, 3, 4, 5, E, 6. And it says this equals 67. Right, this one's not too bad at all. So we just write it out. So it's 2 times 5, which is 10, plus 3 times e, which is 3e, plus 6 times 4, which is 24. And that equals 67. We solve out e equals 11, and we're done. Not too bad. Oh, okay, let's do this one. So if x plus 2 multiplied by 3x squared minus x plus 5 is equal to ax to the power 3 plus bx squared plus cx plus d, what is the value of a plus b plus c plus d? Okay. Nice job to the people who got 21. That's the correct answer. But I'll show you a quick trick to do this without having to expand. So I feel like you guys expanded because that took a while. So you can expand, but it just takes a while. So what's interesting about this problem is if you look at it asks for what is the value of a plus b plus c plus d. So it's basically asking what's the sum of the coefficients, right? And a quick trick to find the sum of the coefficients is if you set x equal to 1 here, then you just get a multiplied by 1, which doesn't matter, plus b multiplied by 1, plus c multiplied by 1, plus d. So that's what you want. And then you plug 1 into the left side, so it's 1 plus 2 multiplied by 3 times 1 minus 1 plus 5, which is equal to 3 times 7, which is equal to 21. So that's a nice, quick, and easy way to solve problems like this. So if you see anything that's asking for the sum of the coefficients, just set x equal to 1, and you'll get the same result. So again, set x equal to 1, it just equals a plus b plus c plus d. So an easy way to do problems like this. Got it? Okay, let's try this problem. Chains, actually let's skip this. Okay, how many distinct arrangements of the letters in the word chair are possible? All right, nice job. This one was made quick and easy. So 5 letters, arrange the words 5 ways, 5 factorial. Nice, yeah, 5 factorial, 120. All right, let's try this one. The arithmetic mean of 90 numbers is 47. 1/3 of the numbers are increased by 6. What is the mean of the new set? Right. Nice job, guys. The answer is 49. Yeah, you can either do it this way, or you can just straight up uh, smash it. So, so if 90 numbers, the mean is 47, so that's the total sum, and then 1/3 of the numbers is increased by 6, so 30 is increased by 6. So plus, this is the new sum divided by 90 numbers again, and then that comes out to be 49. This one's just a little calculation intensive. Okay, let's try this problem, and this will be our last problem before we end the class today. Express the area of the shaded region of in the circle O in terms of pi. Right, so nice job. I think just a small calculation. Forgot to divide by 2 because it's a half circle, but the answer is 12.5 pi minus 24. So the general rule, since even though it doesn't say this is a right angle, because its hypotenuse is on the diameter, it's automatically a right triangle. And because it's a right triangle, we can figure out that the radius is equal to 5. So the total area of the circle is 25 pi, and half the area is 12.5 pi. And then it asks for the shaded area, so it's half the circle minus this right triangle, which is minus 8 times 6 divided by 2, which is 24. Okay, anyway, I'll see you guys next week. Hope you have a good rest of the week. Bye.